This video is a review of section P.7 on rational expressions. Rational expressions are the quotient of two polynomials. What that means is that we are dividing one polynomial by another one. In this case, it's a binomial by a number. In this case, it is a monomial by a binomial. And in the last case, it's a binomial by a trinomial. So you're always dividing one expression by another expression, and that's what creates a rational expression. First of all, whenever you are dividing by an expression, you have to remember that whatever you are dividing by cannot equal 0. So, if you have a variable in that divisor, you have to remember that you are going to have to cancel out anything that will create a 0 as the divisor. So for instance, in this expression of 4 divided by x minus 2 cannot equal 0, which means that x cannot equal positive 2. Because if x is equal to positive 2, 2 minus 2 equals 0, and you can't divide a number by 0. 4 divided by 0, there's no solution to that. So this is called finding the domain. The domain is going to be whatever x can't equal so that the divisor isn't equal to 0. Let's look at example 2. Example 2, we can't have the divisor equal 0, or else you can't, because you can't divide by 0. So in order to solve for this, what can't x equal, we're going to use algebra laws. We're going to add 1 to both sides. That gets rid of the 1 here. That leaves us with x squared can't be equal to positive 1. And then to get x by itself, we are going to square root both sides, because when you square root both sides, you get rid of the x to the power of 2. And that means that x is going to be equal to plus or minus the square root of 1. Whenever you take the square root of a number, you want to make sure that you're going to include the plus or minus sign. And the square root of 1 is always equal to 1, so that's going to be plus 1 or negative 1. And the reason why the square root of 1 is because 1 times 1 gives you 1. And also negative 1 times negative 1 also gives you 1, so that's why we have the plus and negative. So when x is equal to positive 1 or negative 1, it's going to cause our divisor to be 0, and that's not going to work. So when you find the domain, you want to solve for all values of x that are going to make that divisor equal to 1, which is going to involve some algebra, and also might involve using square roots. And if you do use a square root, please do include the plus and minus sign in your answer. So you're going to see that we're going to have a lot of practice defining the domain when what x can't equal when you're working with rational expressions, because you must define the domain along with giving your answer whenever you're working with rational expressions. So the first skill that we're looking at is simplifying rational expressions. We're given a rational expression and we're told to simplify it. Now, whenever you're simplifying rational expressions, the first thing you want to do is factor any polynomials, and this will allow us to cancel out like terms. So for instance, in our first example, we have x to the power of 3 plus x to the power of 2 all over x plus 1. What we want to do is we want to factor x to the power of 3 plus x to the power of 2, and I'm going to do that by using the greatest common factor. X squared goes into both x cubed and x squared. That's going to leave me with x plus 1. And now I have that top numerator factored. I'm going to leave the denominator as is. And then I'm going to cancel out any like terms I find. And I can see that x plus 1 and x plus 1 are like. And when you divide x plus 1 divided by x plus 1, you're just going to get 1. That's going to leave me with x squared by itself. And that is the answer. That x squared is the simplified expression of this rational expression here. Now, as I said, you always have to determine the domain, because you want to say when that x squared when x can't be equal to, and then we see that our denominator here is x plus 1, and we know that can't equal 0. I'm going to subtract 1 from each side. That cancels out that. X cannot equal negative 1. So as part of my answer, x squared is the simplified answer where x cannot equal negative 1, or else you will get a denominator that is 0, and you can't find a solution when the denominator is 0. Okay, let's look at another example. Here we have x squared plus 6x plus 5, so a trinomial divided by a binomial, x squared minus 25. Again, I want to factor where I can, so x squared plus 6x plus 5 gives me x plus 1 and x plus 5. And how you factor this polynomial is up to you. I like to use the grouping by factoring method. That's what works for me, but perhaps you're really good at doing trial by error. Whatever works for you, use. Now, x squared minus 25 is going to be the difference of squares, so I'm going to use x plus 5 and x minus 5 as my factors that way. And now I'm going to look for like factors. X plus 5 and x plus 5 are like, so I can cancel those out. That leaves me with x plus 1 on the top and x minus 5 on the bottom. And that's as simplified as I can get it. And then what I need to do is I need to define the domain. And whenever you're defining the domain, you want to use the very first expression listed as the domain. So that's going to be using x squared minus 25 can't equal 0. I'm going to add 25 to both sides. That leaves me with x squared is equal to positive 25. I'm going to square root both sides. That gives me plus or minus the square root of 25, which means that I'm going to have plus 5 and negative 5 is going to be my domain. So x cannot equal negative 5 or plus 5 in this case. The next skill we're looking at is multiplying and dividing rational expressions. So in this very first example, we have two rational expressions and they're being multiplied together. We're going to look at whenever you're multiplying a fraction, a, b times c, d, that's the same as multiplying the top and then multiplying the bottom, all combined into one expression. So that's what we're going to do. But the first thing that we want to do is factor out anywhere that we are able to. So x minus 7 and x minus 1, we can't factor those out any further, but x squared minus 1 can definitely be factored out to be x plus 1 and x minus 1. And 3x minus 21, I can factor out the 3 and I get x minus 7. Now because I'm multiplying, it's like I'm combining everything together. So I get x minus 7, x plus 1, x minus 1, all over x minus 1 times 3x minus 7. The x minus 7 cancels out, the x minus 1 cancels out, and that's just going to leave me with x plus 1 all over 3 as my simplification. And I do need to do my domain for that. So I'm going to look at my two domains here my two denominators are x minus 1 can't equal 0, and also 3x minus 21 can't equal 0 as well. So when you have two denominators in the initial expression, you're going to have to do the domain to each of those. So I'm going to add 1 to either side for this one, and that means x can't equal 1. And then I'm going to add 21 to both sides here. That leaves me with 3x is equal to positive 21. Divide both sides by 3, and x can't equal 7. So my answer for my simplification is going to be x plus 1 over 3, where x cannot equal 1 or positive 7. Let's look at our second example. In our second example, we have, we're dividing. Now, when you're dividing, remember that a over b divided by c over d is the same as multiplying by the reciprocal. So c over d becomes d over c, and that's what we're going to do here. We're going to take the original, x squared minus 2x minus 8, all over x squared minus 9, but we're going to multiply by the reciprocal of x minus 4 over x plus 3. So it's going to be x plus 3 on the top now, and x minus 4. And that's how you divide using the expressions. We're just flipping the numerator and the denominator on the divisor here. Then what we're going to do is we're going to factor where we can. So x squared minus 2x minus 8 is factored out to be x minus 4 and x plus 3. And x squared minus 9, that also can be factored out to be x plus 3 and x minus 3. And that's being multiplied by x plus 3 and x minus 4. And we can go ahead and cancel out, whoops, maybe not that one, I made a mistake. This should have been a 2, not a 3. Apologize for that. X plus 3 and x plus 3. And what I'm left with is x plus 2 over x minus 3. So you can see that we're left with x plus 2 over x minus 3. That's the answer to this division question. But then we have to deal with the domain. And when we're dealing with the domain, we're going back to the domains that originated with the question. So x to the squared minus 9 can't equal 0, and x plus 3 can't equal 0. So minus 3 on either side gets rid of that. So x can't equal negative 3. And then on this side, we get x squared can't equal positive 9. And then x can't equal plus minus square root of 9, which means that it can't equal plus 3 or negative 3. So our domain will be x not equal to plus or minus 3 in this case. Oh, but just be aware, we also have x minus 4, and if that x minus 4, that denominator, if that's equals 0, we're also going to have a problem. So we need to add on to our domain to include x minus 4 can't equal 0. And of course that means that x can't equal positive 4. So our domain in this case is that x cannot equal positive negative 3 and positive 4, or else we're not going to get a solution to this expression. So you might be starting to see that when we are working with rational expressions, we're keeping the rules of fractions in mind. That when we multiply fractions, we multiply the numerators by the denominators. When we're dividing fractions, we actually multiply them. We just flip the numerator and denominator of the divisor in order to divide. So now when we talk about adding and subtracting rational expressions, you want to keep in mind the fraction rule, that whenever you're adding or subtracting fractions, you must have like denominators. The denominator for each of these rational expressions must be the same in order to add or subtract. And you can see in this example, our denominator terms are the same, so we can go ahead and we can subtract. And whenever we subtract, we keep what's on the bottom, and then we add what's on the top. So we're going to have 5x plus 1 subtract 4x minus 2. And you can see that that's all over x squared minus 9. And you also see that I put that 4x minus 2 within brackets, because that negative, that minus sign, this minus sign is going to affect everything in there. Because now what I'm going to do is I'm going to simplify that top. I leave 5x plus 1, but then I'm going to apply that negative to both terms inside the parentheses. So 4x becomes negative 4x, and negative 2 becomes positive 2 because of that subtraction sign. And again, I keep my denominator because they were like terms. Now what I want to do is I want to simplify. 5x minus 4x. I'm going to combine those like terms, and I get x, and positive 1, positive 2 gives me positive 3, all over x squared minus 9. And my last job here is to factor where I can, and I can definitely factor it, the numerator. X squared minus 9 becomes x plus 3, x minus 3, and the x plus 3's cancel out. That leaves me with 1 on the top and x minus 3 on the bottom. So this is my simplification, but then I also need to know what my domain is. And my domain in this case, x squared minus 9, cannot equal 0. So x squared can't equal positive 9, which means x cannot equal to positive negative 9 square root, and therefore x cannot equal positive negative 3. So x cannot equal to positive negative 3. Now let's look at adding and subtracting rational expressions when you have different denominators and no common denominators. So for instance, in this example, we have 2x minus 3 and x plus 3. So two different denominators. What you're going to do is you're going to use this rule of thumb, which states that when you are dealing with adding or subtracting and you're looking at different denominators, the first thing you're going to do is multiply them together, and then you're going to take the first numerator and multiply it by the second expression's denominator, and then if you're adding, you're going to add the second expression multiplied by the first expression's denominator. So you're going to follow this rule for both adding and then subtracting, same sort of thing, but you're going to be subtracting. So let's see what that looks like. What that does is it provides you with a denominator that's common to both, just like you do when you're working with two fractions that have different denominators. If you multiply the denominators together, then you're going to get a common denominator. So first of all, we're going to take the denominators from the bottom and we are going to multiply them together to make one denominator. So that's going to be 2x minus 3 multiplied by x plus 3. And then we're going to take, in this case, x plus 2, and we're going to multiply it by x plus 3. That's the AD in this part, or I guess I should put the AD over here because we are dealing with the subtraction. So we're going to do x plus 2 times x plus 3, and then we're going to subtract the 4 multiplied by 2x minus 3. And that's going to be our top. Now if it wasn't for this subtraction sign here, we could start canceling out parts of these fractions, but that's only if it was just straight multiplication on the top, which it's not, unfortunately. There's a subtraction sign. So what we need to do is we need to simplify this top. We can leave the bottom as is, but we want to simplify the top. So we're going to go and take this part, x plus 2 times x plus 3, and we're going to expand that out. So x times x gives us x squared, x times 3 gives us 3x, 2 times x gives us 2x, and 2 times 3 gives us 6. And then we're going to simplify this as well. Minus 4 times 2x gives us minus 8x, and minus 4 times negative 3 gives us positive 12. and that's all over 2x minus 3 and x plus 3. Our next step is to simplify that numerator. So to simplify the numerator, I'm going to look for like terms. X squared doesn't have a like term, but I do have positive 3x, positive 2x, minus 8x, which together make, negative 3x, because we have positive 5x minus 8x would be my negative 3x. And then we have 6 plus 12 is going to give us positive 18, and that's all over 2x minus 3 over x plus 3. Next step is to factor where we are able. So x squared minus 3x plus 18. I like to use the factoring by grouping method. So I'm going to do a times c gives me positive 18, and I'm looking for negative 3. So two numbers when multiplied together give me 18, and when added together give me negative 3. So 1 and 18, 2 and 9, 3 and 6. And no matter what I do with my negatives, none of these factors are going to give me a sum of 3, which means that this is not factorable. And because it's not factorable, you just leave it as the answer. So this is the simplified answer of this subtraction of the two expressions. But we also still have to take into account what the domain is going to be. So we need to look at our denominators that we started off with, which was 2x minus 3. That can't equal 0. And we also have x plus 3 can't equal 0 as well. That's from this denominator right here. So that means x cannot equal negative 3. And 2x cannot equal positive 3, so x can't equal 3 divided by 2, so the fraction 3 over 2. So our domain is that x cannot equal negative 3 and 3 over 2, or else we're going to get zeros in the denominator, and that won't work. So in our last example, we saw that there were no common factors in the denominators. But in this example, I'm going to show you, we have different denominators, as you can see, and we're adding these two rational expressions together. There are different denominators, but you're going to see that when we break down these two denominators, we will find that there are common factors, and how that works when we go to solve for this. So the first thing that we want to do is we want to break down the denominators into their factors. So we get x plus 3 on the top here, and x squared plus x minus 2. The factors for that, it is factorable, is x plus 2, x minus 1. And then for our other rational expression, x squared minus 1 can be broken down into x plus 1 and x minus 1. And what you can see is that we do have the common factors of x minus 1, and we have x plus 2, and we have x plus 1. So I'm just rewriting all the factors from both denominators, but I'm not repeating any that repeat. So I have I only write down x minus 1 once, even though it happens twice. I only need to write it down once, and then x plus 2, and then x plus 1, and that becomes my new denominator. So you can only do this when you have common factors on the bottom. So my new denominator is going to be this. Now for the top part, I need to take my x plus 3, and I need to multiply it by whatever factor is missing from its denominator. So it had x plus 2 an x minus 1, but it's missing this x plus 1. So I'm going to go ahead and multiply that x plus 3 by x plus 1. And that will make an equivalent fraction for that one. And then to make 2 into an equivalent fraction with this lowest common denominator, I look at its denominator, which in this case was x plus 1, x minus 1, so that leaves x plus 2, which has to be included in the numerator, like so. So you always have to go back and check what's missing from the denominator that is included in the common denominator here, and then multiply that by the original number. Now I can go ahead and add my whole top expression together. So I'm going to get x plus 3 times x plus 1, whoops, plus 2x plus 2, and that's all over x minus 1, x plus 2, x plus 1. Now I wish that I could cancel out some of these, but because of this adding symbol and I'm not multiplying straight across, I still have to work with what's up top here. So what I'm going to do is I'm going to FOIL out x plus 3 and x plus 1. So x times x gives me x squared. X times 1 gives me x. 3 times x gives me 3x, and 3 times 1 gives me 3. And then I'm adding 2 times x gives me 2x, and positive 2 times positive 2 gives me positive 4. So there I have my numerator worked out, and that is still over x minus 1, x plus 2, and x plus 1. Now I'm going to simplify my my numerator. As you can see, these do take up a little bit of room. So x squared is by itself. There aren't any like terms. I have plus x plus 3x plus 2x. So 1 plus 3 is 4, plus 2 gives me 6. So that would be 6x. And then I have positive 3 plus 4 gives me positive 7. And that's all over x minus 1, x plus 2, and x plus 1. Here I have a trinomial. If I can factor that, I might be able to cancel out some things. So I'm looking at two numbers when multiplied together give me 7, but when added together give me 6. And you can see that there isn't anything that I can do that's going to make that factorable. So this isn't a perfect square trinomial. There's nothing I can do with that. So my answer stays as x squared plus 6x plus 7 over x minus 1, x plus 2, x plus 1. And then I have to figure out my domain. So if the numerator is not factorable, then you just leave it as is, and then you go back and you look at your denominators to see if what you have to cancel out in terms of your domain. So the first denominator I'm going to look at is my x squared plus x minus 2. X squared plus x minus 2, and that can't equal 0. And I'm actually going to use the factors of that, x plus 2 and x minus 1, as my factors that can't equal to it. And then you haven't seen this, but you can take each of those factors and equate them to the 0 or non-zero, and then solve for that. So x can equal negative 2 in this case, and x can equal positive 1. So with that first denominator, if x is equal to negative 2 or x is equal to positive 1, you're going to get a 0. So both of those are going to be included in the domain. And then the last one, the other denominator, so you always have to go back and make sure you take care of both. X squared minus 1 can't equal 0, so x squared can't equal positive 1, so x can't equal the square root of positive negative 1. So x can't equal positive or negative 1. So we already have positive 1, so we just have to include the negative 1 as well. And then that will be the domain covered for this question. The last part of this section is bringing in fractions to these rational expressions. So it's like a fraction within a fraction. You can see that we have the fraction 1 over x subtracting 3 over 2 divided by 1 over x plus 3 over 4. And right away you're like, a fraction within a fraction. Oh, don't I hate fractions. Just take it, the numerator first and the denominator first, and simplify those first before you deal with the big overall picture. So I'm going to walk the talk. I'm going to simplify my numerator. I have 1 over x, subtract 3 over 2. I'm going to combine my denominators. So I get 2x, and then I am going to take my 1 from here, and I'm going to multiply it by the 2 here, and then I'm going to take my negative 3 and I'm going to multiply it by my x. So very much using that rule that we looked at before about how to get equivalent fractions. And so I've done it there, and that's going to give me, with 1 times 2 is 2 minus 3x all over 2x. So that's going to be my simplified version of that numerator. I want to do the same thing to my denominator. I have 1 over x plus 3 over 4. I'm going to combine my denominators, so I'm going to have 4x. That's combining my denominators. Then I'm going to take my first numerator and multiply it by my second denominator. Then I'm going to take my second numerator and multiply it by my first denominator. And then I'm going to simplify that top. 1 times 4 is 4 plus 3x all over 4x. Now I'm going to go back and rewrite my equation with those simplified numerators and denominators. So I get 2 minus 3x over 2x, all divided by 4 plus 3x over 4x. Now remember, whenever you're dividing, it's the same as multiplying. If I wrote it out like this, 2x minus 3x over 2x, and instead used the division symbol and said divide by 4 plus 3x over 4x, you might see that the way to do that is to multiply these two together, but flip the divisor. So put 4x on the top and 4 plus 3x on the bottom. And then you can combine them now. You can multiply the top, 2 minus, well, make sure that's a minus 3x, times it by 4x, all over 2x times 4 plus 3x. Now I'm going to want to simplify this a little bit more. I'm going to take my 4x, that's right here, and I'm going to multiply it by 2, so that's going to give me 8x, and 4x times negative 3 will give me negative 12x. And on the bottom, 2x times 4 will give me 8x, and 2x times 3x is going to give me positive 6x squared. Oh, and I should have saw that negative 3x times 4x would be that right there. So it becomes 8x minus 12x squared over 8x plus 6x squared. Now I like to rewrite the numerators and denominators in descending order of degree. So that's going to become negative 12x squared plus 8x over 6x squared plus 8x. Now I'm going to have to go ahead and find my factors and see if there's any common factors that I can use here. So the common factor between negative 12x squared and 8x is going to be x for sure and 4. So that will give me 3x plus 2 as my inside here. And then on the bottom, I'm going to have 2x as my common factor, which will give me 3x plus 4 on the bottom. And I'm sorry, in my haste, I'm going to put negative 3x here because I have a negative. So 4x times negative 3x is going to give me negative 12x. And then looking at this, I can cancel out these. 4x divided by 2x is going to give me just 2 on the top with negative 3x plus 2 over 3x plus 4. And that's as far as I can simplify. So again, I was able to cancel these out. 4x divided by 2x gives me just 2, and then negative 3x plus 2 stays within the brackets, and 3x plus 4 is on the bottom. And then to look at my domain, I am going to need to look at my denominators that I have. So I had 2x, I had 4x, I had 4 plus 3x. These all can't equal 0. So 2x can't become 0, or else we're going to get a non-solution, and 4x can't equal to 0. So that means x can't equal to 0, because when we divide 0 by 4 and 0 by 2, we're going to get 0. So 0, x can definitely not equal 0. And then we have 4 plus 3x can't equal 0. So 3x can't equal negative 4, and x can't equal negative 4 divided by 3. So that means that our domain, when we identify it, is that x cannot equal 0 or negative 4 over positive 3. So I hope you found that this review for section P.7 is a nice review of what you've been working on and helps to solidify what you already know, or perhaps you're using this as a launching pad before you go into your homework, just to get an overview of the types of questions that you're going to be looking at and the strategies you are going to use. Whatever you use or however you use these reviews is up to you. It can be as an intro to the section, or it can be as a final review. It's up to you. Thank you for watching. Bye for now.